Welcome back everyone to another video. Now I was already planning on creating an AOSP build for the HiKey 960 and might as well thought that to document the whole process and to make sort of a tutorial explaining the various things that can be done while performing this task of creating a up-to-date Android build for the HiKey 960. Now, as you know, this is officially supported by Google, so we'll go ahead to the Android's own website. So go ahead to source.android.com. Once the page gets loaded up, click on source, and after that, go ahead into downloading and building, and then again to using reference boards. So this is the page that we are looking for. As you can see, we have the 960 listed there, and again it just directly say that that Google supports HiKey 960 and HiKey as certified 96 boards as Android reference boards. So yes, they will work. So the first part is to get the whole source code, and to do that, first you have to make a separate directory where you will be storing the source code. For some reason, that portion is just omitted, and if you are doing this for the very first time, I will recommend you going ahead and looking at the overview for hardware requirements and then establishing a build environment, both of which are extremely necessary to get the build working properly. And I would recommend using Ubuntu 16.04, although other people have been successful using Fedora or Arch Linux. But for this matter, just stick to Ubuntu 16.04 since that is the official supported build environment for Android. So the first is to create a directory with the command mkdir. So would look something like this, but since I already have a directory created for it, and I did some steps in advance so that it wouldn't take me too long, so I can go into cd and HiKey 960. I already have that directory created. Now the other step would be to populate it with to initialize a repository, and to do that, this is the first command. Now here the B option means which branch you are using, so that could or have also as well been o-preview or any other Nougat branch, but since we are using HiKey 960, which is basically an AOSP development platform, there's no reason why you don't want to be on the master branch. Might be a little bit unstable, might be buggy, but that is where the most development happens, and that is something that you want to keep a track of. So go ahead and initialize the master branch. That is recommended. Go ahead and do O preview if you want to, but I think master should be good enough. So I have also done that earlier, and then go ahead and do repo sync. Now repo sync is an interesting command. So I've gone through the repo sync process. Now it downloads around 20 gigabytes of data at least, as far as I can tell, and what it does, it populates your build directory with the source code, and it's a big source code. So if you are doing it for the first time, keep in mind that you have enough bandwidth and that this process can take an extremely long time depending upon your internet connection, because it is going to download a whole lot of data. So I will run the repo sync command once again, because again, as I said, this is a very active branch where pretty much everything is changing on a daily basis. So it was a bit old. So let's go ahead and run this once more so that everything that I have is up to date at the point. And here you can tell that the things are being changed. Okay, so the repo sync process is done and we are up to date till now. And as for this time right here, 6th of May, 11:43 a.m. IST, and that is where we are at now. In this branch, changes can happen within minutes or even hours. So the next step is to actually download and extract binaries. So these binaries are related to mostly the GPU drivers and stuff like that. So these are basically drivers that cannot be put into the main source code for on Android because they actually require licenses and are not covered under open source license again. So these are very specifically stored separately and usually are downloaded like we are going to do now. So it's a simple process: copy command and download. um, Wait for it. These shouldn't be too big, since they are just pre-compiled binaries. So this one, and then extract it to whatever folder it wants it to be extracted. I think there would be a license, which there is. So read through it if you want to. I mean, I cannot say otherwise. But you need to be careful before it ends. Oh, see, this happens if you keep pressing enter. You would actually go ahead and end up not accepting it because you press enter too many times. So and caps I accept and press enter, and then as I said, this is the whole Mali GPU kind of thing. So I think this is the user space driver, and the next one might as well be something else, particularly to the CPU that is on the HiKey 960, because I can see HiSilicon's name here. So again extract and then issue the command. And that's that. So this is also stuff to do with graphics. I can see a lot Garlock and hardware composer. So I think that's how the chip is actually taking the Mali rendered stuff and then putting it through the HDMI and through its own hardware. So I think that's all the stuff related to graphics again. So but on more on the chip manufacturer side than on the GPU side of things. So yes, these two were very much related to graphics, and in a closed source environment in these devices, I mean, they even have open source kernels, but graphics is the only thing that remains closed source, and that is one of the main uh, pain of AOSP, that the GPU source is not actually open. So the only two devices that I know of that use a open source GPU is Android x86 and Android RPI. Android x86 works fine, and Android RPI is a mess, as you know it. Mesa is not being very friendly there. So that's it. We have our source code and some binaries that are required to build ready to go. Now before starting the build, this thing won't build the kernel directly. So what you will need to do is separately build the kernel if you want to have the kernel up to date as well. So for that, just skip everything for now. Go into the building kernel part and clone this. So this is just a simple git clone, no repo sync or anything like this, straight from the Android's git. And once that is done, go ahead into uh, cd and kernel HiKey. So cd into HiKey Linaro, and these should be the kernel sources for the board. HiKey 960. And what you want to do is now so what I'll do is, since again I had this downloaded yesterday, I'll go ahead and git pull it once again to see if any changes were actually made, and as far as I'm concerned there should be some. So I think we'll just wait for the git pull to be finished, and that should give us with a few changes which there are, and let's go ahead and start building it. So it says it's already up to date, so maybe there aren't. So git checkout, and that means that we are on the 4.4 branch. So once the 4.9 branch becomes usable, you can actually use the 4.9 branch, but for now we are checking out the git 4.4 branch, and that makes sure that all our files are on the Android HiKey Linaro 4.4 branch. Now again issue the make command, simple stuff. And so I guess for that you would specifically need the cross compiler, but I would just go ahead and first of all issue this command and make J4, because I have 4 cores and why not. So again, this was something that I'm doing it for the first time. So cross compile is I think I have this cross compiler, but I really want to have Linaro's own version of the ARC64 cross compiler. So I'll just Google it, Linaro ARC64 cross compiler Ubuntu install, and that should actually. Alright, so this is the file that we want. It is a x86-64 to AAR64 cross compiler, straight out of Linaro. And what we'll do is copy the link address, open up a new terminal, and here what we are going to do is to simply create a directory, and let's name it ARK64 toolchain. Let's go with the official documentation and just name it that. Not that it makes any difference, but might as well do that. CD into it, and wget the link, the link being this particular file, and control C F V downloaded. It's around 85 megabytes, so shouldn't take too much time. So that's downloaded and then extracted. So tar xvf and the file name. And so once that is done, what we want to do is cd into gcc and bin. Now we have the path here, right here, and now what we are going to do is export this path to our bash rc file. So nano dot bash rc, so it's automatically added to our path, and I think it is being edited somewhere else. No, I don't think so. And then go to right to the bottom, and right here add just a comment, and then export path equals to $path colon, and then this. Now you might also want to replace this with /home and /username just to make sure everything works, and copy this whole thing, Control X, press yes, save. copy this whole thing. Now whenever you next open up your terminal, you can actually go ahead and directly run this without exporting. But since I already have a terminal open, I don't want to reinitialize everything. So here we have, now if I do something like a arc64, we now have a bunch of options available. So you can go either way, but you would need to make one change. Whatever path you choose is to remove the Android options from here. So as you can see, it will fail if I already have the Android option. Go ahead and change that to go and change it to -gnu and then another dash and press enter. Now this should theoretically perfectly build our kernel and shouldn't take that long. Again, I'll get back once the kernel build has completed. Alright, so the kernel has finished compiling, and we still need to copy it to the proper location. Again, going to the reference, here we can see that copy the particular file, which is this, from the kernel directory to the HiKey kernel directory as the same file. So the HiKey kernel directory should be, so cp and then to device to dot dot and device, let's see, Linaro, and then we have HiKey kernel. I think that is where we need to copy it, and yep, and enter, and then we can simply ls this particular directory and see that the image has in fact been copied as, yeah, I mean hi 3660 HiKey 960 .dtb, and that's the device tree binary. Going ahead, we need to copy this particular file to the same directory, I am assuming, as another file. So we just need to add a new file name here, image.gz HiKey 960, and paste, and again that should be available right here. So with all of that copied, let's go ahead to our main Android source and start the build process. Now before we do that, one thing that I know from experience is that my system, even with 8 gigabytes of RAM, does suffer a lot in the recent Android builds, and that is the way Android actually handles those builds, is by reserving part of the RAM to be used by the Java compiler or their Jack and Jill thingy. So the Jack actually reserves a lot of RAM, and it usually is around 4 gigabytes per core, is the recommended minimum specification. So if you have a quad core CPU like I do, I mean 4 logical cores, even though there are only 2 physical ones. So if you have 4 logical cores, you actually need a minimum of 16 gigabytes of RAM, but I have only 8, and that results in failure of build multiple times, and it will keep on happening. So the way to do it is to add a limit to how much RAM it can reserve, and the way is to use the bottom line here, Android Jack VM args, and for the following whole line, and go ahead and add it to so I am in the HiKey 960 source, or let's just do it on the command line. I am on the 960 HiKey source. Leave it that. Go into device, Linaro HiKey and here board.config common, go ahead and add this right on the top, and that should do it. This is just to tell the compiler that not to use more than 4 gigabytes of RAM. So the interesting thing is the HiKey 960 and the normal HiKey don't have two separate directories, just different DTB files, and I think they make it work with that. So that is actually pretty amazing. Though they do have separate make files here, but it's still nice to see in the same folder. So let's go ahead and then now we can start the build process, since we have the jack argument set up so that the jack VM doesn't take more than 4 gigabytes of RAM and crash our whole system. So first of all, let's source the build environment. Now you can use the source command or a simple dot, that should do as well, and that will just set up some essential variables that we use, and launch HiKey 960 user debug. Press enter and it will just take a few moments. So here is the configuration we are going to work with. Platform is O, HiKey 960, and from there ARM v8, and the second is ARM v7. So that's about it, and now we can simply go ahead and issue the make command. Again, I don't know what kind of monsters systems these guys are running on, but J32 is just not possible for me. I will stick with J4, and I will end the audio recording here, and because it's going to take a lot of power, a lot of processing power right now, I'll leave the video recording going on as it is, maybe have some sort of a time lapse next, and we'll see how that goes. Okay, so the build is almost completed. It took me 4 to 5 hours to do it. I also did forget to create the boot image, which is actually necessary to make. And once, if you are using a custom kernel, you can happily use the previous kernel, but if you are in fact using a newly compiled kernel, then it is recommended to create the boot image, because that is what results in the boot.img file. So let's go ahead, and I've connected my HiKey 960 to my PC, and now before powering it on, go ahead and make sure that the pins, there are 3 switches at the back of the 960, and the switch 1 is on, switch 2 is off, and switch 3 is on, and that will make sure that you enter the fast boot mode. Once that is done, it should show up on your device with a simple sudo fast boot and devices, and that is the HiKey 960. Once that is done, we can start flashing. Now all of the fastboot command do require sudo, so I would recommend using that. So the first command, there is a little bit of typo right here. In the first command, it should be noted that this is actually HiKey 960 rather than just simple HiKey. Once you press enter, it does its thing and writes it. It's actually pretty quick. Now let's go ahead to flashing the device tree.img, and then sudo, and that should also be very quick. And then let's flash the system img, paste, and this should take a while, being the biggest file here, around 450 megabytes in size. So what also I'm going to do is not flash the user data, since I already have a bunch of apps on the HiKey 960. I'm not going to flash the user data. I need those for benchmarking and stuff. And what I am going to do is flash the cache, clean it up, and so cache.img and userdata.img are both just simple empty files, so they aren't really they don't really contain anything. Their only purpose is to format those partitions. So again, with cache done, we are actually good to go, and we can actually shut off our HiKey 960, turn the switch 3 to off, and then reboot.